Hi folks, I hope you like looking at schematics because that's what we're going to be doing. As promised, I've made a schematic for the kind of noise circuit that I had a video of the other week. I thought I'd go through it, talk about what it's doing, kind of a bit of how it works, and then I've got another video of just me jamming with the breadboarded prototype. So I'll kind of put that on the end as well. The plan at the moment is to maybe try and get some PCBs manufactured. I was going to solder one up on some perf board, but then once I've got the schematic done, I thought, well, why don't I just get these manufactured? I actually ended up Thonk had a sale. I ended up buying a load of stuff. Like, I got some really cool knobs, and I was just, like I say, I was going to build it on a piece of. Hang on. So basically, I got as far as having my perf board, and I had this kind of wooden box like that something came in, but I thought that'd make a nice kind of thing, and I was just going to go ahead and do it. But I think I'm gonna calm myself down and take my time over it and try and do it properly. Because if nothing else, this is quite nice, and it'd be a shame to waste it on something crap. So yeah, so here we go. Hopefully this will be useful to someone. And yeah, let's go. Right, so here it is. This is the schematic I've made in Eagle. So I guess a couple of disclaimers. This is the first thing I've made in Eagle, so I've hopefully it's. I think I got it figured out. Might have made some rookie errors, and also kind of my usual disclaimer that I'm by no means an expert in electronics. So this is all just kind of figured out as I go along. So with that said, I just thought I'd talk through what some of these bits do. Hopefully that might be useful. Let's see. Yeah, well, let me know if this is something that's useful. I'll do more of this. I actually quite enjoyed putting this together. Once I got the hang of what the hell was going on. So let's start. So basically, it's there's these bits down here that are to do with just the output. There's a kind of little op amp, a couple of op amps here. So that's to do with the output. Then that little bit there, kind of, that's just that, and these bits here are just, I found I had to put a capacitor across the power and ground pins of the ICs I was using, and I just needed a way to represent that on here, so that's what those are. And don't forget to do that if you make this, because it did affect the way it sounded. So that's what those are. And then you've got kind of everything on this side is just a mirror of everything on this side. So it's kind of 2-3 oscillator circuits that then mix together before they go to the op amp bit. So let's dive in to one of these. I'll go over here. So it's using a 40106. In fact, it's using a pair of 40106s. I found that I just got better results rather than loading up a single one with 6 oscillators, doing 2 and doing 3 each. It just sounded better. I mean, that was something that I was messing around with right at the beginning of breadboarding this, when I was just trying to figure out what to do. Could be that there was something else going on somewhere that was causing the problems, because I never went back and revisited once I'd kind of got the overall layout sorted. So you might be able to do this with a single 40106, but I'm just going to leave it as it is. So I'll start down at this bit. So what this here, if I can select it all, ignore that little bit there, but these bits here, that is just a standard kind of 40106 oscillator.
layout. So this is actually, so we're using pins 5 and 6 on the 40106. Pin 5 is connected to ground through an electrolytic capacitor. It's then connected via a potentiometer to pin 6, and then the output comes from pin 6, and the output goes off to wherever it's outputting off to. So that's a standard thing. I've used that loads of times before. In this case, that goes into a transistor, and oh man, I should have looked up the names of the different pins before I started doing this. I looked up some other stuff, because normally I do these videos and I get to a certain point and I kind of go, I don't know what to call that, I should have looked this up. I'll look it up now. The base. It's the base. Right, so, in this case, it connects to the base of this capacitor. So this is an NPN, not capacitor, transistor, NPN transistor, the base of this transistor. The collector is connected to the power, and the emitter goes to this switch. So on pin 1 of this switch, on pin 3 of this switch it just goes to power, and then pin 2 goes via this potentiometer to here, where it is used as it's used as a it's used to control the pitch of these oscillators. So here we have another kind of 40106 oscillator, but this time it doesn't use a potentiometer directly for pitch. It uses a pair of transistors. So this is like, I've been trying to figure out how to do this for such a long time. Part of doing this electronic stuff for me is like, I enjoy the figuring out of it, and like, as much as like, I don't like looking stuff up. I kind of figured, if I wanted to, I could just buy some PCBs that people sell and just solder stuff together and make a load of stuff. But the reason I got into this is just because the process of figuring it out I quite enjoy. The downside of that is it can take quite a long time. There's quite a lot of knowledge you have to pick up from scratch. I don't have any formal training or education on this. I'm just Googling lots of stuff. So I have been trying to figure out how to replace a potentiometer, basically how to add voltage control. I figured there must be some component or kind of collection of components that could replace a potentiometer and allow you to just feed a voltage in to control, essentially to create a voltage controlled resistor. And I messed around with some, oh man, what are these things called? Vactrols. Which is one way of doing it, but it never really. They're expensive, and it was a bit of a pain. And then I figured this out. So I basically bought a bunch of transistors, and I think it turns out that because I'd been just using components that I'd bought years and years ago as like, kind of, you get boxes of starter kits that just have various selections. I don't know what transistors I had in it, but they weren't what I thought they were. So finally, having bought the right stuff, and messing around with it, I've got this. I may cut that giant rant out. So, pin 1 is connected to ground through this capacitor, and it is connected to pin 2 via this kind of pair of transistors. So it goes collector to emitter that way, and emitter to collector that way. And then that goes round, and then that goes to pin 2. Then all of this stuff that we went through earlier, which has got this power coming in through a resistor, because I found you just needed to prevent it from ever having like zero resistance through another potentiometer, so you can control kind of the offset of this pitch versus the master pitch. This goes to both collectors, bases, collector. Oh my god, I looked this up. It goes to both bases. So what that means is kind of the resistance is being changed here. So it's kind of when this capacitor is charging, it's going this way. It's going through this one and round and down there. So through that one. I hope the mouse is showing up on this recording. That'll be a pain if it's not. And then when this capacitor is discharging, it's going through this one. And then kind of round here, out to the output over here. And so you feed the voltage in there, it changes the resistance of these transistors. Man, I need to stop doing that. Changes the resistance of the transistors, and it essentially acts as a voltage controlled resistor. So that is your so that's one oscillator. It's voltage controlled using the voltage supplied by this arrangement down here. So it's either just got power through a potentiometer or kind of oscillating power through a potentiometer. This is another copy of it. The only difference is this one has a switch in front of it, so you can turn this whole kind of arrangement here on and off with that switch. So these two oscillators then both mix together. So we've got these mixing resistors, one there, one there. Oh, didn't mean to do that. They mix together into an LED, which then goes to ground. Then they also mix together down into this switch down here. This on the other side is just an exact mirror. It's a mirror image of everything on the left. So this is all the same stuff, and that goes down into this switch here. So from here you can switch. You can switch either side on or off. So when you have this switch set to just have the kind of power going through a potentiometer, it means that there's just a kind of a stable voltage. If you're not touching this potentiometer, the voltage through here is just stable. So then this potentiometer just kind of is almost an offset from that. So it basically means you have control of each oscillator's pitch via its own potentiometer. Then you have control over the kind of master pitch of both through this oscillator. If you have this set so that the power is coming from here, it's basically doing some kind of I guess frequency modulation. The transistor here is because I wanted to make sure that it was I wasn't sure what the output from here was, and I seemed to get better results if it was kind of modulating 9 volts rather than just taking the output from here. So yeah, it sets up some kind of frequency modulation, so then you get some nice weird tones out of it. If you mess with this control while the others are playing, it kind of just modulates it nicely. So yeah, so we've got to here. You got your switch to turn each side on and off. Down here it goes through a resistor and then into another LED, and then to ground. So you've got 3 LEDs. This one kind of shows you what this side is doing. It is flashing in time with this. So if you've got a kind of audible pitch, it probably looks solid. But when you drop down to kind of where it's not quite audible, you can see it flashing. Same on this one. And then this one is just showing you like a representation of the total output in a similar way. So then we've got a couple of op amps. I'll use the LM358 because it's what I had lying around. So we go into the inverting input, the non-inverting input is just going to the power via potentiometer. I've shared that with both of the... Oh man, I've just realised that is the wrong way around. Let's fix that. That needs to go, and that needs to go, and that needs to go. Because that needs to be going into there, and that needs to be going into there. I guess it looks a little bit neater to look at now, so that's good. So yeah, outputs into the non-inverting input, sorry, the inverting input. The non-inverting input comes from this, so you've got a potentiometer controlling the voltage into there. The output of this one goes into the inverting input of the next one, and then it outputs to, I've just got that as header pins for now, but you know, if you wanted to put your jack socket there or whatever, that's where that goes. So I found that this isn't strictly necessary, but it just makes it sound more interesting. It kind of makes it sound a bit nastier. It does boost the signal level slightly, probably not so much that it's important, but it just kind of, this was designed to be noisy, so a couple of kind of gain stages makes it noisier. And another thing to point out is, like, op amps is something I've not done a great deal of messing around with. I don't feel like I've kind of got it in the way that I've got a lot of other stuff. So all of this, not that, all of this and that over there could probably be done loads better. So you know, if you have a suggestion for how, I was kind of almost trying to go for a kind of high gain distortion type thing. Oh, I've missed some resistors out. Because of course I have. See, that this is what happens when you're kind of just trying to use this stuff for the first time. Yeah, this bit's just wrong. That's not what this is doing. Okay, so that was just wrong. So this is this is what it actually is. I'm glad I caught that now. So let's start again. This goes into the non-inverting input. The inverting input is connected to ground by a potentiometer and is connected to the output through a resistor. The output goes into the non-inverting input of the next one. The inverting input is to ground through the same potentiometer, and then to its output through a resistor, and then the output goes to the header pins. That is the two gain stages. Save. So yeah, so that's basically it. I've got this bit down here is just because my plan is to create a board layout and have some like prototype boards made, like manufactured, because I've wanted to do that for ages because I think it's really cool. So that is just to make sure that there's a way of giving it the power and ground. So that's another set of header pins, just like a pair of pins. Oh, and actually the other thing that I need to do, that I guess I may as well do now, is if I move that, make a bit of space there. Let's make a bit of space there, and a bit of space there. Move that, because what I need to do is grab a capacitor from somewhere. Oh, that's weird, is that? That shouldn't be like that. Man, yeah, the more you look at it, the more I noticed dumb errors. I'm obviously going to have to like give this a real close kind of inspection before I do anything else with it. But you know, I do these videos. I want to share the screw ups as much as the successes. So because you know it's how you learn. I'd rather people see me do something dumb and then hopefully fix it, and then they don't do the same dumb thing, than they make the same dumb mistakes that I make. I did this on my breadboard, so I need to experiment to see if this is strictly necessary now that I've got kind of the same thing on the ICs, but just putting a capacitor across the power and ground kind of rails. Again, it just helped. It just solved some kind of weird things I was seeing, or hearing rather, not seeing. But again, that was fairly early on in the process of coming up with this design. So, and I've not revisited it, so that might not be like a requirement. So let's talk values. In the design, in the video, so by changing the values of your capacitors and your potentiometers, you can have different kind of stuff happen. It basically changes the pitch ranges and whatnot. So in the one in the video, I've got one side I'm using 100k pots and I think 2 microfarad capacitors. Let me just see if I can see one. Okay, so I've got 100k pots, 2 microfarad capacitors. That's for these ones. This one is a 10k pot, and that is a 10 microfarad capacitor. And I might even have to have a rethink of that, because I might just be able to use 100k pots across the whole thing and change the capacitors to do what I want to do. On this side, I've used the same value capacitors, so I've got the 2 microfarad capacitors, but I've used 500k pots. So that means that it'll the pitch of these oscillators will go right down into entirely inaudible. It'll go down to like more than a second between kind of changes, because I've been using this just to generate kind of rhythmic patterns as much as I have as an oscillator. That's not to say that you have to do that though. It's kind of occurred to me as I've gone along that there's quite a few opportunities to use this for different kinds of devices. So, I mean, if you just mirrored all the values on both sides, then you just get some. That's a much different kind of thing to. You could probably use even bigger capacitors or higher value potentiometers on this side and make some really kind of really long kind of evolving patterns. What other values do I need to tell you? All of the resistors, anything that's protecting an LED, I've used 5.6k, just because that it's some that I had lying around, and it made the resistor kind of the right brightness. So like these ones, that one there, that one there, that one there, that one there, and that one. Oh god, that's not going to happen. And that one here. All of the rest I've used 1k. I think the ones that I've used for mixing, all of the outputs could arguably be higher value, and that'd probably change the sound. I have a suspicion it might make it less noisy, or maybe more noisy. I don't know. I have a suspicion it'll do something. But I could keep. I basically decided I just have to get as far as I want to take this, and then build it. And then maybe I'll come back and do a second revision and change some stuff around. But otherwise, I'll go mad. It's like I don't know, like when you write in music, you have to just choose a point to say it's done. Other things that I think could be interesting that aren't on this schematic, but I'm definitely going to look at for a potential kind of second version, is it wouldn't take much to, I don't know, for argument's sake, instead of having that go into power, have that go into the output of all of like this side. So basically connecting that bit there to there, or even a third one of these connecting to there, so that one of these switches between a simple oscillator and a and and a more complex kind of oscillator, or maybe even use a switch with more positions, so that it also just has standard standard stable voltage. That could make some really interesting noises, I think. Other things, I think I wanted to mess around with using some kind of triangle waves to control this. So like maybe have, instead of taking the square wave output from this, take the triangle wave. But that's another that was lost to me having to decide how far to take it before I just call this one done, because it needs some kind of, maybe another op amp or something to boost up the triangle wave. I did try it just straight out and it didn't work. Basically, you take the output from over here instead of over here, and you get a triangle wave. But it needs kind of boosting up to be useful for anything. So that could go to, from there to the base on this transistor. Because I figure you could then use a high value capacitor, so you get some really kind of slow triangle waves, and then you'd get some kind of audible ramping up and down of the pitch on these oscillators, and again, that you could start getting some really interesting sounds from that. I'm tempted. I'll have to have a think about how this would work. Like, the easiest way to do some interesting stuff would be replace that with a pair of header pins, and then just say, because you can get kind of header pin jumpers, say if you want it to just be power, then you just jump it to the other header pin. Or if let's say you built two of these, you could take the output from one into there or into there. I don't know. Maybe stick a switching jack there, so it comes from here if you've got nothing plugged in. Otherwise, you can put your own kind of voltage source. In fact, that's probably the way to do it. In fact, I've got some Phonicon jacks that I might do that with, so I'll have a look at putting that in there, and then kind of add some really basic modular functionality. Because I think the places I've been looking at to get a board manufactured, like, have a minimum order of like 5 or 10 or something. So I'm going to end up with a few copies of it, assuming it all works. I could make more than one, and chain them together in some interesting ways. So yeah, that is this. Like I said, there's probably mistakes. Man, if you see some mistakes and you want to point them out, please comment. I've already learnt stuff from people commenting and either telling me I'm doing something dumb and suggesting another way, or even just asking questions. There's some of this is like I don't know how to do something because I've just never considered it, and so it's also nice to just be prompted to think about stuff that I've not thought about. Um, I'm gonna put up a I'm gonna put up a link to I'll export an image of this. I'll put up a link to it. It doesn't have resistor or capacitor values on it yet, or potentiometer values, just because I haven't figured out how to do that in Eagle. I'm sure it's really simple. I just haven't got there yet. So I'm gonna do that. And yeah, hopefully one of the next videos I do will be talking about doing a board layout, getting it manufactured, which will be quite exciting. Um, so yeah, we'll look forward to that. Hopefully, life has been getting in the way of doing these videos quite a bit lately. So hopefully the next one won't take another however many months this has been. But yeah, thank you for watching. Hope this was useful, and I will talk to you next time. Laters.